Hello,
All right.
everybody. Welcome to the monthly Fortran call. Our schedule for this call is we'll discuss FPM for about 20 minutes, and then we'll do stdlib for 10 minutes, and then we'll discuss about what was achieved in the past year. I'm going to share my screen, and we'll start with FPM. So in the past month, there has been a lot of activity. I'm now at the GitHub page for FPM. You can see all the closed pull requests. And as you can see, a lot of people contributed. Lawrence was the most active, and Sebastian was also very active. And I submitted also. I submitted one in a long time. After a long time, I actually submitted some pull requests also. And it seems so. One thing that probably the most important thing is that FPM can now be bootstrapped from a binary by going to the README and then clicking on the link. For every release, there are now a set of binaries for Linux, Mac OS, and Windows. And those binaries are generated from the Fortran source code of FPM. And so, for example, if I just click on that, download it, and then go to downloads, it's the FPM. Oh, then you have to, I guess, make it executable. And then you can run it just like that. You can see it's a statically linked executable, and you can run it, and it has the commands to create, to use it. The way I do it on my computer is I do. So I have a bin directory, and in the bin directory I have it's just a symbolic. Or actually, I copied it to the bin directory directly. A bin directory is in my path. So if I, go somewhere to a new place and do FPM new, I guess I have to do some name of the project. Let's say T1 will be my first project. It creates the my Fortran project, and then I can do FPM run, and there you go. And you can see it's working. And so FPM is really usable and really easy to use now. So when you modify it, you do FPM run, it recompiles it and runs it. And what you see here, that's the Fortran version of FPM. And it's clever enough that if you don't modify it, it runs it right away. So that's, I think, was a huge news, I think, from last month really. A couple of days ago. And so it works on a Mac and Windows. And then in terms of the pull requests, I think the main activity was to get the Fortran version to work. And in fact, one thing that I'll show you is, I'll kind of do it from scratch so you can see that I'm not cheating. If I clone the FPM repository, just like from scratch like this, and go in there, and the actual FPM Fortran source code is in the FPM subdirectory. All I have to do is FPM run, and now it's downloading all the dependencies and compiling them. So now it's doing the toml f, the mcli dependency. So it downloads them first, I think. I guess this one has a lot of stuff in it. Now it's compiling all the dependencies as well as FPM. And I guess there are some warnings, we should fix those, but it will finish it, and there you go, and then it runs it. So it took just a couple seconds, less than a minute, and we are up and running. And then if I do it again, then it just runs. So now it's running FPM, so it's kind of running itself. But you can see, if you modify it, I don't know, maybe in the main file. I don't have a good example to modify, but if you modify it and rerun it, it will pick up the changes. And you can see how easy it was to work with the dependencies, which are specified in the FPM toml file. So those are the dependencies, and there are some tests. Don't know if they work or not. Well, I guess they do. Yeah. So FPM test executes the tests. So you can see this is very usable. It's just incredible that it now hosts itself, all implemented in Fortran. Yeah, so that's the main thing. Milan, do you have any kind of comments to it?
No, but I have a question. Are there any, probably mainly for Brad, because he has been on top of the latest developments, are there any current sort of maybe unsettled discussions or things to work out, discuss, maybe regarding the UI, the arguments, things like that?
There's a little bit of discussion, I think mostly settled on what install will default to do. Let's see, what was the other one? There's some discussion around adding benchmark and examples as some additional executables to be supported, and kind of a minor change to the UI so that basically FPM run will take a flag as being test, example, app, or benchmark. So it will run one of those sets of executables instead of just being able to run the default executables. And I think that's headed in the right direction. Let's see what there's still a lot of discussion around how to support custom flags and supporting multiple different compilers and stuff like that. But at this point, it's still kind of a really tough technical problem that we haven't really found a good answer for yet. So there's plenty of discussion to be had there.
Is the discussion happening in the issues?
Yeah.
Issues and pull requests,
Yeah.
I would say.
Yeah, little bits and pieces keep coming up here and there. We just really haven't had a real focused effort on really solving the problem directly.
Okay, so there's a few things. Let's first ask Andre and others here on the call what they think about the FPM install default. So at first I thought that it would be nice to by default install everything, but after good arguments that I read in the thread, I now agree that by default we should be installing only the executable, so what's under app. So you don't install the library, you don't install tests, examples, that stuff, but you can provide a flag if you want to install library at your own risk. And risk could be, okay, just name conflict, version conflict, whatever. It all goes into the same install directory. So if you're doing this with multiple versions, there's no infrastructure to handle different versions right now. So I agree with the opinion that, okay, by default we install only the binary, and the user can still give a flag if they really want to install the libraries. So I don't think this one is controversial anymore. Maybe it's John Urban that is maybe on the other side, but I'm not sure. But I think most people support installing only the binary as a sane default. Andre, does this all make sense to you? What do you think?
That's what I would do, and I think that leaves us the option later to, we can install more if needed. How does Cargo do it?
I don't know, Brad.
I think it only installs the executables as well, but I'd have to double check to be sure.
We should look at it, but if they also do it, then I would just do it also, just the executable.
What happens for projects that deliver the library rather than executables?
Yeah,
so the goal of FPM is that you don't have to install a library in order to use it, right? You use FPM, which fetches it and builds it for your project. So there's not strictly a need to ever install a library once everything is in FPM. That's the end goal. Obviously, there's use cases where some people do still want to install libraries, so we want to support that option. But the default use case wouldn't have a need for it.
I think Lawrence, so he raised this argument that the issue with installing Fortran libraries is that because of incompatibility between modules compiled by different compilers, it's kind of hard to yeah, to install in a way that would be like portable across compilers. In fact, if I think of the FFTW library, like they just ship interfaces so that you can just include their the interface with an include statement in order to just avoid this problem.
Yes, so I think that's exactly right. And so I think installing the binary is a no-brainer, and we can do it, and that'll be useful immediately. It's a separate question how to deal with libraries, and I think it's a valid use case. I would like to use it myself to be able to use FPM to install a library and then use it from a project that doesn't use FPM. In fact, I would love to use FPM to install dependencies for a production code that, let's say, does not use FPM. So the question is how to do that, and the answer is not easy. But it seems that in Fortran, it seems that the most common convention is to install the module files into an include directory. At least that's what I've been using, and I think that's what CMake uses also. And so FPM could do the same thing, that when you do FPM install and add a flag library, it will install all the modules into some kind of include directory that you can then include in your project. So that's what I would suggest.
This would need to be then right for each compiler version you are using with FPM, like have a separate directory.
Yes, not just a compiler version, also compiler flags, I think. Oh, I'm not sure about that, but I'm pretty sure. In fact, I think that's how we do it already. If you look at build directory and let's say the dependencies. Okay, sorry, it will be the. I guess you see it right there in the build directory. You see the G-Fortran debug and G-Fortran release that I think contain. I assume they contain the module files. So.
But related to that, maybe a question: if you at point want to ship your executable or your program as a normal package like in Ubuntu or RPM, I mean, I understand that probably for developers that's not really needed if you use FPM, but at one point there should be an easy way to say, okay, now make it use dynamic libraries from the system instead of downloading it. And of course, then it's your responsibility to ensure that the version matches. But if you want to put it on a Linux distribution, it would be, of course, users not so nice to install FPM additionally, even though many people get used to use pip for Python already. So.
Yes, right. It's an excellent point. I would love FPM, and it's not just Ubuntu. It's, I would say, other platforms as well as package managers such as Spag, Conda. I would like FPM to play very nicely with those. In fact, people, let's say from Spag, already reached out to us, and they would love to collaborate on these things. And so we should ensure that that it's easy to use FPM. Sort of kind of be able to customize it so that it can be used easily. And so, for example, in Ubuntu, you're right, every library should be a Ubuntu package. I think that's how they do it. And so there needs to be some easy way to call FPM to install the module files to a location that you give it and install it. And also, well, how to use system-wide libraries, that's a little bit separate question. But at the very least, it should be able to use the FPM libraries from the system. In other words, that you create an FPM library for FFTW, and then you create another FPM library for your application, and your application should be able to pick up the module files from the FFTW. If you see what I mean.
If we're going to start supporting, using FPM to distribute packages through these kind of like binary package managers, like, the system-wide package manager or something like Spag or Conda, then we need to standardize on what compiler and flags, well, maybe not flags necessarily, but at least what compiler is used to generate those binaries and libraries.
Yes. And I guess part of it is we will have to kind of design it, but it looks like we should install the module files, and also we should install some kind of either a JSON or TOML file that explains what's in there or how to use it, so that when you, let's say in Ubuntu, as the FFTW package installs the module files, sort of like what you see on the screen right now, but it would also install some kind of FPM file, let's say JSON, that would contain kind of explain what's in there, so that when you depend on it, let's say in your application or in Ubuntu, in a separate Ubuntu package, you can pick up and use it. So that FPM can figure out how to use it properly. I think it's similar to how CMake packages work. When you have a CMake library and you install it using CMake, it creates, as long as you use the feature, it creates a CMake file, package file. It's called CMake package file, which contains the information I just described. And so then when you, in a separate main code or separate library, you use it, you just do find package, I believe, in CMake, and you set up the paths. And as long as you do, CMake reads that file, the package file, and knows everything it needs to know. And so I think that's a mechanism we'll probably have to design how to do. The reason we did not have to do it up until now is because FPM handles the dependency themselves. And so FPM TOML has everything that's needed. But that's, in some sense, we can think of it as a source package. But in order to make it easier to, let's say in Ubuntu, which is a binary package manager, I think we need some metadata with the installation.
I mean, I'm not 100% familiar with how I mean, I know that CMake, for example, can build Debian package. And so the question is really if FPM should be able to build binary packages, then
Okay.
I'm just commenting, then we need to do what Brad mentioned, that we need to take care of the compiler flags, and the speak easily can take out your application out of FPM and then distribute it as a normal and use the Ubuntu tools or Debian tools to create a package. And because they are usually relatively strict on what they consider as good compiler flags.
So one, I would warn, well, we can do that, but my experience with Ubuntu and Debian is that they are very particular how they want to install, what they want in their packages and where. And so we can make, create a command fpm build Debian package, and of course we can try to follow the Debian and Ubuntu guidelines, but I think even easier is to just concentrate on building from source and let the Debian and Ubuntu people, developers, create those packages themselves, as long as FPM can be used in a way that it just works. And the features that we have to implement is installing a library and the module files in a directory that they specify, and then also when they build, let's say, a package that depends on FFTW, so that FPM can pick up such an installation. And as long as that works very robustly, then the Debian will figure it out, and Fedora will figure it out, and Spec is a source, but Conda will figure it out. And so we don't have, and so we can down the road, of course, make it even easier. Do like FPM create Conda package, and it would just create the package that you can then install using Conda. That'd be great, but it's just that my experience is that let's say the Conda developers, they might prefer to maybe package it a little bit differently. And so we should provide, as the first step, we should provide the source level installation as I just described.
Yeah, I totally agree.
Just one question. I haven't followed the discussions that closely, but how does it work on Windows with its different platforms? In the for the OS module in the standard library, we have been looking at the various platforms, and is there any experience yet with the way FPM works on Windows?
Arjen, I think you might be the only one using Windows right now.
Right, okay.
Steve uses Windows too.
There were some comments on the Fortran discourse. I think some students started to use FPM on Windows. And of course, there were some issues on how FPM worked on the different platforms, but I think then Lawrence solved it and he updated the binary. So perhaps you can just try downloading the FPM executable and giving it a try.
Yes, that's something I would like to do then. The past couple of weeks have been very busy here, so I had no energy left to do anything about it. But it seems that the coming few weeks, last part of this year, is quieting down a bit. So that may give me some room to do that.
You're looking for somebody to test FPM on Windows, is that right?
Yes, just see how it works.
I'll give it a try, see what it does. I haven't played with it yet.
Steve, you could totally use it to build your Advent of Code program.
Yeah,
it'll be very easy.
I'll give that a try. Yeah, okay.
So I think it only works with Fortran for now. Am I right?
No, I believe most of the compilers now have support in there. We at least have default flags in there for the Fortran version now.
Does it work with Intel?
I didn't have very much luck with it, but it wasn't FPM's fault. It was the Intel compiler's fault on Mac. It was just giving me grief about some of the code that I was trying to do.
So I think, Steve, if you and
I can try i4, I can try NAG, and I don't have Fortran currently installed, but you guys are already doing Fortran.
Well, I have to install Bing W, so that should be two extra cases.
Well, yeah. We'll see. Okay, I'll give it a try.
Thank you. And you can report any, create an issue on the FPM repository with anything that doesn't work, and we'll work on fixing it. Okay, so let's move to let's see what's next. So we have FPM update on the current status, documentation of the command line interface, new functionalities. I think we discussed all of this. There is FPM update and FPM dist. I'm not quite sure what that is. Does anybody know?
I think there are some preliminary discussions about creating like the distributable binary packages, and then for FPM dist, and then FPM update is about trying to figure out if we can update the dependencies in your TOML file.
Okay, yeah. So I think we can continue those discussions on GitHub. So if you don't mind, we can wrap this up and then go to stdlib. So Milan, go ahead.
Excellent. Okay, so maybe best to share my screen. Let's see. Okay, so I see that Jeremy joined. So I'll just go ahead and maybe do a retrospect of what's built so far in stdlib, and then if Jeremy is available, maybe he can just discuss the most recent issues and pull requests. So so far we have I think about a dozen modules. They're kind of scattered in functionality, and most of them only implement parts of features that you commonly find in such modules, but some are fairly complete. So early on, even implemented handling ASCII character set. Recent addition was the bitsets module. I haven't played with it. To be honest, like right now, I won't even know how to play with that, but I'm sure the docs explain it well. If you think that bitsets may be useful for you, that would be good to try out. I personally don't have a use case. I think the error module just defines that one check subroutine, which currently used just as a placeholder for easy testing within stdlib, and perhaps some error codes, or no, I think yeah, bitsets and one other module currently implements their own error codes, but we should discuss at some point in the near future on consolidating the error codes into a dedicated module for that. There's the IO, so that's something that Andre worked on early on with convenience functions like save text, load text. I think NumPy has that. And also a bit higher level interface to the open. So you can now open a file with like a read write or an append string like you would do in Python, rather than specifying all those action status, whether it's sequential or direct access, those kinds of things. So now you can just pass it a short abbreviated string and get the unit number back as a result, and then do read write inquire operations that you need. And then the kinds, that's just I think an internal small module that provides kind constants. Linear algebra, I'm not sure what this has right now. Let's look.
Doesn't
Okay, I
have
think
much.
this was
Just
yeah.
has so creating the identity matrix and extracting a diagonal and the trace.
Trace, got it. Okay.
I had two more functions in preparation, but I haven't found the time to finalize them. Maybe this Christmas.
Very good. And then we have Logger. So that was recent addition, mainly by Bill Clodius, and Jeremy helped out a lot with that. I play with it. It's pretty nice. I think I'll start using it in my own project so far. I mean, so far, I was always kind of rolling my own thing with just minimal stuff that I needed. But this is a relatively nice and simple solution. It's the API is pretty high level, so you get a derived type that you can create an instance of, and you can have as many different loggers as you want. Or you can use, the module also provides a global logger constant, which it's already instantiated. So you just pull in that variable from the module and initialize it, and then you just log. And this, the way this is designed and implemented, I think you can just readily use it in parallel code as well, with each image or MPI process having their own logger instance, logging to a separate file. Then Optival. So Optival is a convenience module. It implements only one procedure. It's called Optival. And basically it's just for easy handling of optional dummy arguments. So you can call Optival with your optional dummy argument, which may or may not be present, and you can provide a default value, which is assigned to the dummy argument if it's not present. And otherwise, it does nothing if it is present. So that's already used within other stdlib modules. Then we have Quadrature. So that just has two different methods to numerically integrate a function: Simpson's method and trapezoidal. And then stats, that was mostly led by Jeremy, I believe. It has 5 basic statistical functions, which what you commonly see, say, in NumPy. So correlation, covariance, mean, moment, and variance. There was recently a question came up either on Discourse or in the issues, I'm not sure which, that basically asked whether we should be able to pass 2 array arguments for correlation, covariance. So currently it takes an array that has an extra dimension of length 2, which allows you to pass, say, 2 1D arrays. I think that's for covariance. But another common API is that rather than passing a single array with that kind of shape, you pass it to 2 one-dimensional arrays. And Jeremy has also opened an issue for that just to track it sometime in the past. So that's probably just a matter of implementing a specific procedure to match that interface. So as of right now, it's probably just open for discussion on how does this look like, and what would be best to tackle next. I have some opinion on that. Now, from what I can tell, we didn't have much of a roadmap in implementing it. I think people were implementing things as per their own interest, availability, the code that they already had laying around that was in relatively good shape. So these things were sort of low-hanging fruits to implement, but we didn't necessarily follow like the highest priority items to be implemented first. And this has recently seen some criticism on Twitter. So, for example, one thing that I would personally benefit most from being implemented in stdlib, but I don't have maybe knowledge or skill enough to implement it myself, is a high level string implementation. Now there's various implementations laying around. Brad has isovariant string implementation. Aryan has one, and many others have. And this has been, I think, a long discussion in the issues about how best to tackle strings. And I don't think we have a good solution right now. What's the most desired API? Should it be a derived type that you instantiate and it comes with methods? Should it be more low level? Should it be both? Generally, stdlib has been having a philosophy of having both low and high level interfaces to do things, because they're both useful for different applications. It makes sense that we were focusing on lower level first. So at this point, I'd just like to ask for feedback from everybody here. What do you think about specifically going forward with strings in stdlib, and what would you like to see implemented in stdlib? Or in other words, what would make you use stdlib?
So with the strings, I think we can move forward pretty quickly. So last call, we discussed the split. And if you notice, the split is using the allocatable string that's in Fortran itself. And I think we can very quickly add other such similar methods working on the low level for iterating for Fortran, allocatable string. And then on top of that, we can build some derived type if there is interest, or if people would think that would simplify some of the, let's say, having an array of strings of different lengths, stuff like that. And I think it seems to me that most of us are in agreement regarding this.
May comment from my side. I think the varying string in modern Fortran is okay, but what is missing is a list. I mean, I come from Python, and actually want to have is just a list that can store strings of different lengths. But the varying string length essentially is there. It's just the issue that you always need to put it into an array, and by that making the length the same. So if it's not very difficult to write a list, code for a list, but of course with all the type checking it gets complicated. But something like a list or a dictionary, that would, in my opinion, really help. But to implement that with strong typing is of course relatively complicated.
Wouldn't the solution be what I suggested, to use the string derived type and have an array of that derived type?
Yeah, you could hide the array character of that in a list derived type or something. So you have a high level interface to a list, and underneath you have an allocatable array.
Right. And so stdlib can provide this high level interface also. So people can choose.
The pattern that I've typically been using has been relying on the ISO varying string implementation that I have, which is basically, it provides a derived type where the internals are completely hidden, but it provides the intrinsic routines overloaded, so you can just use it as though it were a character for calling all the intrinsics.
Yeah.
And then I typically just kind of use those wherever necessary. And you can put them in an array. And so the basic idea is, like, I have a string that behaves as though almost as though I had a typical default character type, but I can put them in an array. And I found that pattern to work pretty well. And generally I've also then, in places where I'm using that, if I'm writing a library that I want to be able to take, my routines need to be able to take a string in, I'll provide both in an interface where it can take either a character or one of those varying strings.
Right. And that would be, and so what I was thinking is having this probably ISO varying string or something similar as the high level API in stdlib, and just like exactly how you described, that stdlib would provide both the low level and high level, and overload the intrinsics, or the functions. I think that the lib would fix it for everybody.
Maybe a comment not related to strings directly. So I think what would help maybe speed up stdlib development is once it becomes usable as a FPM package. So I think early on the problem was FPM couldn't yet resolve submodules which are used, and I think now perhaps the limiting thing is use of the 5pp preprocessor. But I think if this is solved, then it becomes usable.
Yes,
So
we should do that for sure. I think that's something we should concentrate on. So there are two ways to solve so I think the only issue is the preprocessor. So there are two ways to solve it. One is or three ways. One is we on the stdlib side, we pre-generate those Fortran files, either as a tarball and upload it to releases or any other way. I'm not a big fan of checking it to Git, but that's also an option. And then FPM would not even need to know about the preprocessor. It would simply use the Fortran files. The other way to fix this is that FPM itself can have a mechanism to somehow call the preprocessor. What I had in mind initially with the stdlib is that stdlib itself would simply provide the generated files. That way end users don't have to worry about any preprocessor, don't have to have Python installed, don't have to, and it should work easily on all platforms. Let me know what you think. Which way do you prefer?
I'd say indeed without the need for a preprocessor, because it would scare people who are not used to that sort of things.
Yeah.
It's also my point of view. I think providing the F95 would be a good thing.
That's what I also like more. Okay, well, in that case, the question really is, how do we provide the generated files? And there are two principal ways. One is to check it into the Git. I'm not a big fan of that because those are big files and really they're not meant to be modified by hand. The other option is to generate a tarball, release tarball. And let's say the FPM already, we have the mechanism to automatically upload the binaries. So for stdlib, I was thinking of having a similar mechanism that uploads a source tarball for every release. And the source tarball will already contain the generated Fortran files. And then FPM, does FPM have a capability to download the tarball?
Not yet, but that I think we're right at the point where that's kind of the next critical feature is we need a way to download tarballs, and we just need a centralized registry where you upload a source tarball, and that is the FPM registry that gets used by default, right? So if you just want to say, I want to use this package with this version, by default, it goes to FPM's central registry and downloads whatever tarballs have been submitted there.
So
that's the way almost every other package manager works. So
the registry has some issues to, it's we should fix it. But what I was thinking of to even get it even sooner is we can specify that. Oh, I see. FPM wouldn't know where to go for. Like, no, sure. So if you specify a dependency on stdlib, that instead of giving it the GitHub repository, you would give it the tarball URL from the release page on GitHub.
Right.
And I think that we might be able to implement it quickly.
Yeah, that's a good first step, is just to say where now we have you can specify a Git repository and it uses Git to fetch that one. If you just specify a URL, it assumes that it's trying to download a tarball and it'll unpack it for you and use that.
Perfect. And then on the stdlib side, Milan can then lead the effort to do the CI. I think Lawrence, I think he knows how to do that.
Yeah, thanks for volunteering me, Andre, but that CI is really not my strong side.
Lawrence knows to do that. We have to convince him to do that.
Mm-hmm.
I have a question now about this. If you choose to go down that way, would that mean that then any package that needs to be pre-processed, you'd recommend making a release tarball of pre-processed source files and then just downloading them from URL? Would it maybe be short and kind of more beneficial in the long term to actually pre-process on the FPM end?
Yes, but in the short run, I would recommend to do the tarball way, and the reason is that it's very robust. We don't, and we are very close to be able to do that. In the long run, it'd be nice, but for that, I would advocate to have not depend on Python, because it's a pain to, on all platforms, ensuring that it's installed and dealing with that. Rather, we should have a preprocessor, well, I guess in Fortran, and be able to do that and then FPM itself can pre-process. And in that case, yes. And the only, I would say, I don't know if it's already clear that the FYPP preprocessor is the way to do it for everybody. We kind of chose it for stdlib because we needed to choose something, instead of writing the generated files by hand. We knew that we have to generate them. So we just chose FYPP because it could get the job done. But the question is, moving into FPM would mean that we are recommending it for everybody. And I don't know if it's maybe a little bit early. Maybe we want to get maybe more, I don't know, use it in stdlib a little bit longer, and also provide the Fortran implementation of FYPP. Or I don't know, what do you think? Or do you think you would recommend it for every project to use it?
I'm not sure how much I would recommend a preprocessor because it's no longer standard Fortran.
Exactly.
So I'm on the fence. So I could do it either way.
I think at the moment it's a good idea for providing generic interfaces. In the long run, of course, we hope that generics is possible within Fortran itself.
Yeah.
I would really prefer not to have to rely on preprocessors.
I agree. So It seems to me that so we should wait with that and rather concentrate on the short run, which is do the tarball, and then in
Exactly.
the long run we should investigate if Fortran. I'm on the generic subcommittee at the J3, and I will, if anyone of you would like to help with that effort, please contact me. I will. There's a lot of work on that front. And I think in general, and I think I'll ask Steve if he agrees, but I think in Fortran, I would prefer not to need to use a preprocessor. I would like to just use the compiler and the language itself. Steve?
Oh, I couldn't agree more.
Okay, great. So there you go. So I think that answers it.
Just a crazy idea for the future. Maybe FPM could be also a preprocessor, and if it's implemented with a really attractive and powerful syntax, and if people started putting that into their projects, that would also provide us kind of a quote-unquote vendor lock-in for FPM. Just an idea, not a serious recommendation right now.
I've had a thought along those lines, but primarily because my interest in this aspect is I would like to have a way of having my unit testing framework find my tests for me, so I don't have to regenerate a main program for it. And it would be really awesome if the program I wrote in Fortran to do that search and generate the main program for me, I could put a directive or compiler directive or something in the main.f90 file that actually just ran that program and put the source in before it compiled. So if I had a perfect world, that's the kind of functionality I would like, right? So I can write some Fortran that gets called when it's compiling my Fortran. That would be the perfect world, but I don't know how far we are away from that. That might be a while.
In general, I would prefer if FPM can just call Fortran compilers as opposed to kind of having its own additions to the Fortran language. I feel it's more, it's better, at least in the short run. But since we are short on time, let's discuss these things. Brad, for example, would you mind opening an issue and describing this feature? And let's discuss it in GitHub. Let's move to the close of business. So Milan, do you want to say a few words about the past year? We have 5 minutes.
Not really. I don't know what to say from the top of my head.
Okay, well then I'll say it. I'll share my screen. I think I can do it in 5 minutes.
Excellent.
I'm gonna do a new. So this is a private window, and now I'll do a DuckDuckGo first, and I'll just kind of show you. So if you type Fortran in there, literally the second link. So there are some 2 ads. So we just skip it, and then it's the Wikipedia for Fortran, and then the Fortran line. So our web page is the second one in DuckDuckGo. If you do Bing, and then you do Fortran, there you go. Second link right there, fortranlang.org. And then if you do Google, and then you do Fortran. So in Google, I think it's the 5th right now. It kind of oscillates 4th, 5th. So that we just made a tremendous progress. And the page, I think we put it online in May, if I'm not mistaken, or April. So it's less than a year, and we already got to the front page in every browser. Every search engine. And so that to me, it's like something I thought it's impossible to do, in fact, and we've done it in less than a year. So it's just unbelievable. And so what I would like to do kind of in the next year is, keep doing what we are doing and providing good content. I would like to have some better tutorials at the page. And with the compilers that I would like to kind of spend more time and contact the vendors to provide us better pieces for each, better kind of paragraph for each compiler, and the documentation that will be in the learn section. I have a better kind of improve the documentation so that every time I need to kind of point somebody to how to do something in Fortran, how to get started, I can just point them here. And in general, I'm very excited about the progress so far.
I agree. it's been beyond my expectations by far.
I might ask, Milan, when will your blog post be available?
Oh, I'm so sorry. So I've been working on it, but kind of very slowly on and off. I actually want to send a draft to a few of you this week.
Nice.
Yeah, but
Okay.
I'll make sure to let you know. Aryan posted a question about stdlib OS. Martin, do you have any comment about the current status and whether we can start putting it in a pull request for stdlib?
The microphone of Martin is off.
Yeah, I see his message.
Yeah.
Okay.
Yeah. Okay. So I hope to find some time in the next month, and then hopefully, I mean, of course we can go ahead, but there are probably a few small things to polish. But I think Arjen did most of the work for Windows, so it's really ready.
Could we help you for moving forward, or what does still need to be done for stdlib OS?
I think one point, but that we can do during the inclusion, is the question about the names. The names are short, like, I mean, basically direct takeover of NumPy, but some people prefer to have longer names, so something like directory instead of dir. And then there are a few things where I just wanted to have a look, where I think it's probably better to do something at compile time and not on runtime. But I guess, I mean, it won't change the interface, so it can be also done after it's included because no one will notice.
Yeah.
Well, thank you. We can
That
discuss
sounds great.
in issues.
Yes, and it would be a good idea that if people start using it, I think.
Yeah.
It'll be very useful for FPM too.
Yeah.
Exactly.
Yeah.
Yes. Okay, so the hour is up. Thank you everybody for joining us, and Merry Christmas, and we'll see you next year in a month.
Thank you all.
Thanks, everybody.
Bye, everybody.
Bye.
Bye. Thank you to
Bye.
Tracy.
Bye.
Bye.
Merry Christmas.